Welcome back to the Python Praxis. In the previous video, you have learned about control flow and how it works inside your programs. Now in this third part, we will go one step further in control flow. We will learn more control flow techniques and more commands that Python offers us to use in our programs. And not only that, we will also learn some shortcuts that allow our code to be more compact and more human readable. And of course, we will study more actual projects using Python. So let's get started. Sometimes one decision leads to another. That is when we use nested if conditions. In Python, you can place one if statement inside another. This is known as nesting. Nested conditionals are useful when you want to make a second decision only after a first one has passed. In the example of the coffee order assistant, we have an if-else condition that checks if the drink is coffee and prints the necessary message each time. In case the drink is coffee, prints the message, preparing your coffee. In case that the drink is not coffee, which means that the if condition is false, it prints the message, sorry, only coffee is available right now. A second if condition is placed nested inside the first if condition, and in case the drink is coffee, meaning the first condition is true, checks whether to add sugar in the coffee or not. If the variable wants sugar is true, prints the message adding sugar. Otherwise, if the wants sugar variable is false, prints another message, no sugar added. When you're writing Python code, and you know you'll add something later, but for now, you just want your program to keep running without errors, Python gives you a useful keyword, pass. Think of it as a temporary placeholder. It tells Python, yes, I know this block is here, but skip it for now. This is super useful when building bigger projects. Use pass to inform Python that you will complete this part later, and Python will not break your code at that point. To see a small example for the use of pass statement, let's look at these code lines. In the first line, we ask the user to enter a command, and we store the value of it in variable command. At this stage, we have prepared only the block of code for the first if condition and the else block of code, but we are not ready yet with the elif block of code. So what we do? We write our code as usually, with the parts that we have already prepared. And at the elif block of code position, we put the pass statement. This way, our program will not break when checking the elif condition and will continue to the else block of code. Sometimes programmers want to make their code more human readable. We know that a condition is always evaluated as true or false. So when it comes to Boolean variables, it is common practice to use them directly rather than explicitly checking their value. For instance, we have a variable called sunny, and we set it to be true. Instead of writing if sunny equals true in a conditional, we can simply write if sunny, and Python will understand the same thing. And thus our code is shorter and more human readable. For the same reason, Python allows us to use condensed forms in simple if or in if-else conditionals. A simple if that contains only a single instruction can also be written in a shortened one-line form. The syntax is if condition, colon, and then the statement. Likewise, an if-else condition where both branches consist of only one instruction can also be compressed into a single line. The syntax in this case is statement 1 if, then the condition, then else, and last statement 2. Statement 1 will run if the condition is true, and statement 2 will run if the condition is false. Let's see also two examples of condensed forms. In a simple if conditional, instead of writing a whole block, you can do if x is greater than 5, colon, print x is greater than 5, all in one line. Or even shorter with an if-else conditional. You can write all in one line the following: print positive if y is greater than 0, else print non-positive. This way of writing code is not always recommended for beginners, but it is good to know because you will see it in real-world code. Let's deal now with a bigger project, a robot battery checkpoint. We are programming a robot diagnostic system. The system receives a battery level from 0 to 100. The robot model code, that is a string like Rx or Tx or something else, the number of hours the robot has been operating. Based on the input, the program will format and display the battery status as a 2-digit number, followed by the % symbol with leading zeros if needed. respond differently depending on the model type. In case the model code of the robot is RX, a message will be printed saying that it is a standard maintenance bot. If the model code of the robot is TX, another message will be printed saying that it is a high-performance unit. And if the model code of the robot is anything else, a message saying it's an unknown prototype will be printed. The last task of our program is to check if the robot has been running for more than 10 hours, and if yes, to calculate how much energy it should have used, assuming it consumes 7% per hour, and alert if the battery left doesn't make sense. The code for this project is like this. In the first 3 lines, we ask from the user to type in the data from the robot, the battery level, the robot model code, and the hours of operation. And we store these values to the corresponding variables. The battery level and hours of operation input, we also convert them to integers before storing them to their respective variables. We must do this conversion every time we need to store numbers, because the input statement returns everything we type as a string. The next 2 lines of code format and print the battery level with 2 digits and leading zeros. To do this, we use a new string variable named battery str, and then print the battery status message. The next block of code in our program contains the if, elif, and else conditions and statements that check the model of the robot and respond with the appropriate message. The first if condition checks if the model of the robot is RX. And if it is true, it prints the message, model RX detected, standard maintenance unit. In case the if condition is false, Python proceeds to the next line and the second condition check. Using the elif for the second condition, we check whether the robot model is TX. If this is true, Python prints the message, model TX detected, high performance unit. In the case that also this condition is false, the code proceeds to the else statement and prints the message, unknown model, prototype, or custom built. So at this point, our program has completed the second task. In the last part of our code, we have the battery usage logic. We start with an if condition to check whether the operating hours of the robot are more than 10 hours. If this condition is false, our program ends there. But if this condition is true, the program proceeds to the next lines. Firstly, calculates the expected usage of the battery by multiplying the hours of operation of the robot times 7. Then, using an if condition, checks whether the expected usage is greater than 100. If it is true, it reassigns to variable expected usage the value of 100. We do this because there's no physical meaning for a battery usage greater than 100. If this condition is false, Python advances to the next line of code. Here we have another if-else condition. This if condition checks whether the battery level of the robot is at a reasonable level, considering the amount of time that the robot has been operating. This if statement checks whether the battery level is less than the expected, which is 100 minus the expected usage that was previously calculated. If this condition is true, it means that the robot is consuming more than expected. And in this case, our code prints the warning message, warning, battery level is lower than expected. Possible drain issue. In case this last if condition is false, the else block of code is executed and the following message is printed. Battery usage within expected range. Great work. This exercise ties together operators, if statements, and real-world decision-making. It is a fantastic capstone for this lesson. And that wraps up Lesson 5, Operators and Control Flow. In this lesson, you learned how to use operators to calculate and compare, and how to guide your programs with if, else, and elif. You even built a robot diagnostics system. Not bad at all. Remember, operators give your program power, and control flow gives it intelligence. Together, they turn code into something dynamic and interactive. In our next lesson, we'll go even further into Python, building on these foundations. Until then, keep practicing, keep experimenting, and as always, happy coding.